Welcome to section 2.1. We're graphing quadratic functions and looking at general equations of them. I'm going to start with the intro, which is f of x equals x squared. And so looking at this function right here, we're going to graph it. We know some specific points, 0, 0, 1, 1, 2, 4, and negative 1, 1, negative 2, 4. And you can look at this parabola. Okay, if you look at the questions that come next, we're going to ask you these same things on a quiz and a test. What is the vertex? The vertex is the point where the two parts meet. This vertex occurs at 0, 0. The line of symmetry is the vertical line that basically cuts your graph in half, and it shows mirrored images on either side. And so in this case, my line of symmetry occurs right here on the y-axis. You cannot say y-axis. You have to give me an equation, and the equation for the y-axis is x equals 0. And so every axis of symmetry, as we look, is going to come from the x coordinate of my vertex. So keep that in mind as we go through. In the second part, we're going to start with x squared, and we're going to use our transformation ideas from chapter 1. We want a vertical stretch of 5, right 3, and up 2. And so as I go to write my equation, I'm going to call this G. The vertical stretch of 5 comes before my parentheses. And because I'm moving right 3, I do the opposite. So it's x minus 3. And I'm talking about parabola, so I square it. Up 2 is a plus 2 at the end. Now, you can graph this using either your calculator or plugging in some points. I'm just going to give you the general look of it, but one thing I can tell, this is the h and the k, if you remember from chapter 1, and h and k is my vertex. And so in this case, my vertex is 3, 2. And you'll notice I'm moving my origin, and I'm moving it right 3 and up 2. And so my new vertex is going to be there. And I'm stretching it 5. So instead of going up 1 and over 1, basically to get to my first point, I'm going to go over 1 and up 5. So 1, 2, 3, 4, 5. And so I'm going to get a point that's right about here. And the same thing will happen on the other side because it's symmetric. And so you're going to get a graph that looks something like this. Now, where is the line of symmetry? Again, the line of symmetry cuts my graph in half. And so what is the equation of this line? Well, it's x equals 1, 2, 3. And again, I'm going to revert back to the fact it's always the x coordinate of my vertex. Okay? We're going to talk in general terms. We want this general equation. So as we look at it, we want a vertical stretch of A, right h, and up k. And so my graph h, this is the general form. A times x minus h squared plus k. And so as you go through, this is this general equation for a parabola or a quadratic. Keep that in mind. The vertex is hk, and my axis of symmetry occurs at x equals h. And so we're going to be, our goal today is to get all of our equations in this form, and a pre-calc book calls this standard form. Okay, and so our goal today is to get every equation looking like this instead of ax squared plus bx plus c. Okay, so let me slide down. We're going to do a couple of those. The definition of standard form, again, let's go back through that equation. F of x is a times x minus h squared plus k. Okay. The axis of symmetry is the vertical line x equals h, and the vertex occurs at the point hk. If the value of a is greater than 0, our parabola will open upward. And if a is less than 0, then our parabola will open downward. If you want to just use up and down, you can do that too. But this is the general idea. We did this in Algebra 2, but in Algebra 2 we called this vertex form. And so the hard part about this chapter in pre-calc is this is considered standard form, so please keep that in mind. Our goal is to be able to take an equation and tell me things like the vertex, the axis of symmetry, shifts, left, right, up, down, stretch, shrink, things like that as we're going through. So I'm going to start with this example A. The question is, where's the vertex? And the vertex occurs with h and k, and it's always going to be x minus h. So as I look at it, it really is the opposite of what's in the parentheses. So my vertex occurs at -3, -5, because I'm moving left 3 and down 5. So left 3, down 5. The axis of symmetry is always an equation, x equals, and we take our x coordinate from our vertex. If I ask you to describe a transformation, let's look at this. We would say stretch of 6, and maybe we should say vertically in there too. We would have going left 3, and we would have going down 5. And these are all the type of things that are coming on the first quiz, so I want you to keep in mind. We will ask you to describe transformations, tell me vertex, tell me axis of symmetry. Okay? You'll notice in the second example, example B, it's not in standard form. So our goal here is to put it in standard form first, and then we can actually answer all of these things that are going on. So, all right, let's look at this. We know we want to get back to something with a parentheses squared. So I want to look at the fact that, can I factor? Is it possible to take this quadratic and factor it? Well, in this case, yes, because x squared is x and x. 49 is 7 times 7. And so I end up getting a parabola that says x plus 7 squared. So we're having this in standard form. The only thing that's different, the number in front here, I don't have a stretch or a shrink. It's just like there's a 1. And I'm looking for, what do we do up and down? I'm going to put a +0. Normally we don't put this 1 and we don't put this +0 in, but I want it at least for discussion at this point in time. So if I look at this now in standard form, and again, if we asked you to put it in standard form, here's the equation we're looking for. Where is the vertex? Well, the vertex comes from the left, right, and the up and down. This says moved left 7, but don't move up and down. So my vertex is -7, 0. The axis of symmetry then is x equals -7. Okay, and the only description then we have for this transformation for this graph is to move left 7. We're going to get a little harder, but we're going to take the same idea. We're going to try and factor things, and if it doesn't factor, I'm going to show you a different method. So flip to the second page. All right, take a look at this first one, letter C. Can we factor this? You always want to ask yourself first, can you factor it? Well, x squared is x and x, but 5 is only 1 and 5, and that would never equal 12. Because of that, what we're going to be working on today is called completing the square. Okay, so we're going to work on completing the square. And this is not a topic that we talked about in Algebra 2, so this is new. What we are going to do is basically we're going to group the first two quantities, and we're going to try and make that somehow the x plus something squared. And so what I'm going to do is I'm going to put x squared minus 12x, and I'm going to put a little blank here because my goal is to fill in something there that would help us complete the square. And so what I want to end up doing is saying, okay, x times x would get me x squared. What number times itself would get me a value here, but would add together, so what two values added together to get me -12? Well, if I have to take a number plus itself, then I've got to have -6 times negative 6, or negative 6 plus negative 6 gets me negative 12. When I multiply these two together, I get a positive 36. And so whatever I do here, I don't want it to affect my original equation. So since I added it inside the parentheses, I'm going to subtract it on the outside. Now I'm looking at this, and again, my goal is to write something squared. I used a negative 6 in order to get 36. So my parabola is x minus 6 squared. And so what I did is we call completing the square so that I could end up making this. And then what I'm going to do is combine these two together to get negative 31. This now is my equation for my quadratic in standard form. And if you took this original equation and plugged it in your y equals, and took the second equation and plugged it in your y equals, they should be the same exact graph. Okay? So looking at this, my vertex then is at 6, negative 31, which gets me an axis of symmetry at x equals 6. And now I've walked you through one kind of in general. I want to show you this short, I don't know necessarily the shortcut, but a shorter idea. You'll notice that this negative 12, if we would have taken this and divided by 2, we would have gotten the negative 6 that we needed. And so basically as you go through, you're going to take your b value and divide it by 2. And that's going to get you the value that goes into our parabola. Let me try that again so you can actually see that. So we're going to take our b value and divide it by 2. That's actually going to be our h quantity for our vertex. Okay? So that's the first idea. I'm going to walk you through a couple more that get a little bit more difficult. But take a look at D. This cannot be factored. Okay? So what we're going to do, though, you'll notice if I group these two, you always want to say, is there a number? And only take out a number. Okay, so only take out a number. What we want to do is take out a number that they have in common. And if you look at it, you'll notice they both can have a 3 taken out. So x squared plus 4x. And then again, I'm going to leave a space because I grouped the first two. And my goal is to use those first two numbers to complete the square. Okay, so again, I'm going to ask myself, how do I add to get 4 by using the same number? Well, it's 2 times 2. 2 times 2 gets me 4. 2 plus 2 gets me 4 as well. And so this 2 value is the value I'm going to use for my parentheses. So it's going to be an x plus 2 squared. Again, what you'll notice, if I would have taken 4 and divided it by 2, I would have also gotten the 2 that goes there as well. So keep that in mind. I'm going to use that one the next example. Biggest thing though, I added a 4 in the parentheses, but there's a 3 outside. So this 3 times 4 is what gets added. So I'm going to subtract a 3 times 4 because that 3 would get multiplied to the 4 as well. So I have here 20 and then a minus 12, which is a positive, let's try that again. 120, I apologize. 120 minus 12 is a positive 108. Okay, so this now is the equation of my quadratic in standard form. Once I look at this, then the question is, okay, where's my vertex? My vertex occurs at -2, positive 108, and my axis of symmetry is at x equals -2. We're going to try one more example, and then I'm going to give you the general form of it so you can kind of see what's going on. All right, take a look at E. Again, we're going to group the first two, and we're going to take a number out. So I'm going to take a 2 out. I'm left with x squared minus 8x plus something, and I've got this plus 9 at the back. We have said all along, if you take this b value and divide it by 2, then when I go to make my parabola, this is going to be a -4 is the number that I'm going to use. And if I take a -4 times a -4, I get a positive 16 added to the equation. Don't forget though, this 2's in front. 2 times 16 got added. So we're going to subtract 2 times 16. And basically 9 minus 32 is negative 23. So here's the equation of my quadratic in standard form. My vertex then occurs at the point 4, negative 23. And my axis of symmetry is at x equals 4. So again, easiest way, take the b value and divide it by 2. That's the number that goes in your quadratic in standard form. That's your h value. And you square your h basically to get the number that goes in your perfect square. So let's talk in general, shall we? I'm going to take these first two and I'm going to group them. And basically we always take that coefficient out. So I'm going to take an a out. And I'm left with x squared plus b divided by a times x. Because I had to take an a out of this, and I don't know what it is, so I just took b divided by a. And then I have this c at the end. Okay? What we said is basically take this b value and divide it by 2. Dividing by 2 is the same thing as multiplying this by 1/2. So what I end up getting is an x plus b over 2a. Okay, because if I multiply b over a times 1/2, I get b over 2a. So I wanted you to see where that's coming from, and I've got this a outside. And we said, basically, take this value, b over 2a, and you square it. So b over 2a squared would be what I end up adding into my parabola. So now I look. We always multiplied the a times this last quantity. Since it got added in this case, we're going to subtract it. A times b over 2a squared. And it's going to take us a little bit of work to be able to simplify this. So I'm going to put that down here. Here's what ends up happening. I have c minus a, and I'm going to square each of these. So this square gets distributed to all three. So I have b squared over 4a squared. And this a will cancel with one of the a's on the bottom. So I really have c minus b squared over 4a. And so this is the value that I'm going to add over here, plus c minus b squared over 4a. So where is my vertex? Well, okay, it's a little messy, but we'll go there. It is negative b over 2a, because remember this is a plus, so it's the opposite. And then c minus b squared over 4a ends it. Where's my axis of symmetry? I'm going to write it right below. X equals the opposite of b over 2a. And this is the general form, and it's a little messy, but again, I want you to kind of see how it's working kind of as we go through. If you would like me to go through this in class one more time, please circle star at something and we can do that as well. So I'm going to slide down here a second and kind of finish up. As we look, again, the vertex of the graph is basically, we said our x value is, this all comes from part F. The x value is the opposite of b over 2a. How do I find the y value? Well, I plug in the opposite of b over 2a into my function. So this basically just says the y value when I plug in my x. Okay? If a is positive, then the parabola will have a minimum at the x value. And again, here's the idea. If my parabola is, if a is positive, then I'm going to have, and I don't know where it is, but I'm going to go like this. I'm going to have this minimum down here at wherever my vertex is. If A is negative, I'm going to have a maximum. And similar idea, let's say it's over here. If my parabola is here, my maximum is going to occur again at a vertex. And those are things that I think you should know. We're just using a little bit different notation with this opposite of B over 2A. We talked about it in Algebra 2, we just didn't go too far in depth. This last example is a perfect quiz question. Actually, I love this question, and I believe you have one on your homework as well. But take a look. They tell you that a vertex is at 5, 8, and it passes through this point 7, 12. Can you give me the equation in standard form? Well, let's talk about standard form. Standard form is A times x minus h squared plus k. All right, let's plug in what we know. I know my parabola's vertex is at 5, 8. So this is going to be a negative 5 and 8. I also know a point, and they give me the x and the y. So the x is 7. I don't know an a, but I know my y is 12. And so our goal is to simplify, solve, find a, and then rewrite my equation. Okay, so here we go. 7 minus 5 is 2, and 2 squared makes 4. So this is 4a plus 8 equals 12. When I go through and solve, 4 equals 4a, and I divide both by 4, a then is 1. So I know my a value, and once I know my a value, I'm going to use my a value and my vertex to write my standard equation. If a is 1, I don't need to write it, so I'm just going to start my parentheses, x minus 5 squared plus 8. Okay, and again, you can put this 1 in here, but we don't necessarily want to see it. Try another one of these. Again, most of the time you'll find an a value, and so you'll just stick whatever your a value is in there. But in this case, I would not put the 1. Okay? Again, questions or concerns, please circle star at Come See Me in the Morning. But thanks for watching section 1.2. I'm sorry, 2.1.